Just a little bit of housekeeping. We want this to be an interactive webinar and to keep it as relevant and useful to you as possible. So that being said, everybody is muted right now during the presentation portion, but you're welcome to unmute yourself if you have a specific question or a thought or a comment that you want to pipe in about. And you can also feel free to type those questions into the chat box, and we'll kind of be monitoring that as we go. As I mentioned in the email that was sent out, this isn't, your typical webinar. There are going to be breakout rooms later, which we hope that you'll be actively engaged in. So stay tuned for that. And feel free to turn your video off during this point in the presentation, but please do turn it on during the breakout rooms. It just kind of allows for better conversation and a nice flow. Lastly, we scheduled this webinar until about noon. We won't go past that. So thanks in advance for your thoughtful and your active participation today. Next, Bart.
Next.
So kind of what we're up to, the big goal of this webinar is to explore different kinds of data that can be supportive of your MWEEs and other environmental education programs that you might be offering. As you know, BWET funds MWEEs, of course, but we also strongly encourage the use of NOAA resources. And these resources include data, but they're also other things like lesson plans, online activities, and other sorts of things that we can go into in another webinar. But today we're going to be specifically focusing on kind of 3 bins of data, and that's water quality, weather, and climate. And we're going to give you a few examples of websites within each of these categories, and then we'll break into groups to kind of explore one in depth. So to kick things off, we want to recognize first that there's so much knowledge between the folks who are sitting on the line with us today. We hope that you'll share that. So continue to share through the chat after this webinar. But first, we wanted to highlight just a few BWET funded projects that are using data in interesting ways to support the MWEE. And so something to kind of consider in all of this, that using data looks like different things, whether depending on the grade level, the subject area, but it could include data collection, which we're going to see in both of these upcoming examples. It could be accessing data from long-term data sets, or it could be kind of a combination of both of these, collecting and comparing long-term data to understand different patterns and different trends. So when we're using data in the classroom, we want to be analyzing and interpreting it, and then the collected and accessed data should kind of fit within the scope of the question that you're investigating for your MWEE. So these 2 case studies do a really great job of doing just that. So I'm gonna see if Anne might be able to. Anne, do you want to try one more time to see if we can hear you?
Can you hear me?
We can. Awesome.
That's yes?
That is a yes. Awesome.
Okay.
So I'll turn it over to you.
Okay, thank you. Welcome everyone. I'm Ann Strozik from the Howard County Public School System stationed at the Howard County Conservancy. And I'm here today at Glenelg High School, and I'm thrilled to be sharing how we've been using our data through the Howard County Watershed Report Card. There's 2 main ways that we've been collecting data. The first way is we've developed a schoolyard assessment where students have an opportunity to go outside and collect data on many variables. And it's interesting because they've walked by a lot of these things in their schoolyard and have never thought about it from a watershed lens. So just to give you a quick snapshot of what they test for, they measure the amount of tree canopy coverage in their schoolyard. They compare using maps impervious versus pervious surfaces. They look at many different types of pollution in their schoolyard, from the parking lots, the oil on there, the erosion, storm drains, downspouts. They do soil compaction tests. And one of the most troubling spots for them is actually when they conduct their trash survey around the school area. But as always, we like to include something positive for the kids to examine. They evaluate the existing environmental features that they have in their schoolyard, such as rain gardens and native plants and stormwater ponds with fringes, stenciled storm drains. So in terms of the schoolyard, the big takeaway, as I mentioned earlier, is they gain a new perspective for their schoolyard. They gain a new perspective in watershed education, specifically stormwater management. And they go back to the classroom after they collect this data and really analyze the data and make decisions on how they want to advocate for their schoolyard based on the data. And this political age, I really like to encourage, authentic thinking and real science. And it's just a stepping stone for a lot of our freshmen to making, further decisions in terms of like later voting or possibly kind of taking a bigger step into environmental decisions. Next slide, please. The second big way that we engage students through data collection is taking them to their closest stream. And these are all freshmen in Howard County taking biology, GT, and earth science. And during the stream assessment, they perform a cadre of testing. They look at the amount of cloud cover and contrails. They look at the physical corridor, so looking at the amount of embeddedness in the stream, the erosion on stream banks. In addition, they look at water chemistry, pH, dissolved oxygen, conductivity, water temperature. And then, of course, the real big story, the benthic macroinvertebrates, the life of the stream, where they're using the macroinvertebrates as indicators of stream health. And so for a lot of the students, they really walk away unexpectedly loving the stream experience because knowing that they're going to turn all of this data into a grade for their watershed report card gives them a real sense of purpose. In addition, a lot of our students have never been in a stream before, so having that opportunity to not only be out inside of nature, not have it be scary, and to do something real with the science is very exciting. So once again, just like the schoolyard, the students go back to the classroom, analyze the data, and make recommendations for their stream based on what they collected. So that's it for me.
Thank you so much, Anne. That's great. The kind of informed decision making of this project is really, I feel like, important and something fantastic to highlight. So Frank, do you want to chime in and tell us what KKPON has been up to, how you're using stream data to support your MWEE? Frank, I'm unmuting you, so try to chat now.
I hope I got that right.
You did.
You hear me okay?
We can hear you. Thanks, Frank.
Good. Good morning, everyone. Frank Rogers. I'm director of KKPON Institute. We maintain the Potomac Highlands Watershed eSchool on our website. It's an interactive, animated platform for teaching K through 12 students about their watersheds and their connection to rivers and watersheds. The tools we have on there is represented by the CBIGS buoy, the Chesapeake Bay Interpretive Buoy System, which you can see on this. When you click on that CBIBS, it'll take you to the next slide, which is our Potomac Highlands Watershed eSchool. So there, the image in the upper right is the web page that you would land on, what we call our real-time data page, where we have links to, well, real-time data from NOAA Weather Service, National Weather Service, also USGS river gauge stations, and finally the Weather Underground. And one of the links is to the Mid-Atlantic River Forecast Center, which you can see in the background there will produce a map of all of the locations where NOAA and USGS are maintaining river gauge stations. Next slide. The way we use this with our students, we have them collect rain gauge data at their school. And one of our favorite things to do is set out 3 gauges, one in the open, one under a deciduous tree, and one under a pine tree. And the students will learn how forest canopy intercepts rain. So that the students collect their own rain data at the school, and then next slide, they can then use our website, our real-time data portal, to access the NOAA Mid-Atlantic River Forecast Center gauges, and they can record the gauge height at a already put us on hold. There we go. And then so they find the gauge, they look at the map, find the gauge closest to their own school, and then they look downstream to find a gauge station that's further downstream from their location. And then they can compare how their daily graph of rainfall compares to the river gauge station near them, and then also how that compares to further downstream. And if all goes well with their mapping and their data collection, they'll see that there's a time delay from when there's rain where they are, how that impacts their local stream, and then further on there's a time delay for the rain to reach downstream and have the gauge downstream rise as well. So it's a chance for students to collect data on their own campus and then relate that data to downstream to see how they connect. And this is available not just for West Virginia. Our real-time data portal has links to across the entire Chesapeake Bay watershed. So we have gauge stations in the Susquehanna, Rappahannock, etc. And that's it for us. That's our little ditty. And then, of course, we hope that this will lead in our MWEE to the students seeing the importance of trees and how they intercept rainfall. And then we do a hands-on conservation project with the students around trees, either planting them, maintaining them, such as mulching, or even doing an inventory of the trees on their campus. Thank you very much.
Thank you so much, Frank. So those are two examples of, BWET projects that are kind of been in the works for a little while, have utilized different sources of data, and really, built out their programs and made them more robust through that. So thanks to both of you for sharing. And both of these projects, I think, really get to engaging students in authentic issues, hopefully issues that are life relevant, and then using data to practice that informed decision making. We're talking about like those if-then statements, claim evidence reasoning, and kind of recognizing that we live in a time when data literacy and being able to back up a claim with real vetted evidence and then making informed decisions on how to act or respond or push forward is really what it means to be an engaged citizen. And one of the cool things here is that your students will be, collecting data and engaging in informed decision making, and that's really just what NOAA as an administration does as well. We're collecting these huge amounts of data. Thanks, Bart. We're collecting these huge amounts of data to make informed decisions and to help folks think about managing and protecting resources. You can go to the next slide now. So to piggyback on that informed decision making and those other 21st century skills, we know that working with data is a critical piece of what students need to learn in the classroom through next generation science standards and other standards that are more or less based on these. So in this kind of three-dimensional learning, there are those cross-cutting concepts, science and engineering practices, and the DCIs. And hopefully throughout this presentation, you'll be able to make some of the connections, but just a few things to call out. Many of the cross-cutting concepts are a natural fit for working with data. So cause and effect, patterns, scale, proportion, quantity, and really all of the 8 practices can be achieved using data. One of them specifically calls out analyzing and interpreting data. So just wanted to make that connection for folks. And then finally, next slide. Using data has the potential to connect these singular investigations that your students are undertaking into the bigger systems conversation. So for example, if you're thinking about how rainfall is impacting living resources, maybe how it's impacting blue crabs, let's say in Crisfield, Maryland, you're also, thinking about and leading to questions about what does it mean for the larger watershed? How does a decline in blue crabs impacting other organisms? How is it impacting our economy? What are we seeing? Why are we seeing this more increased rainfall to begin with? And what are the causes of those changes and rates of precipitation? So data is really the springboard for connecting these different systems and painting the bigger picture for students. I'm gonna turn it over to Bart now to talk with us a little bit about a couple of tools and resources for accessing water quality data.
Yeah, so thanks, Elise. And so in the spirit of making informed decisions, one of the data resources that we wanted to highlight is the Chesapeake Bay Interpretive Buoy System. So this is a system of 10 buoys that go from the Susquehanna River where it empties into the Chesapeake all the way down to where the Chesapeake empties out into the ocean, the Atlantic, in at the first landing buoy. But the point is, like, this data is being collected, ideally 24/7, 365 days a year, to do exactly what you heard about others doing with their data, right? Supporting informed decision making and providing a resource for education purposes. And like Lise called out, like in terms of cross-cutting concepts, you can look at some pretty classic patterns in the data available on the CBIB system. Patterns about like how salinity changes in the Chesapeake Bay over the course of the year, which is key for like when the critters that live there do what they do. You know, spawning and reproduction is cued largely based on both temperature and pattern. So these temperature and salinity, I'm sorry. And there's these annual patterns in these things that you can see by looking at that data and use to kind of almost, in some cases, predict, you know, when things like a sea nettle might appear in the Chesapeake Bay. So powerful tools to look at that. And like Elise also mentioned, like cause and effect relationships or correlations. So one of the classic things about how estuarine systems and ocean systems work, and it has to do with dissolved oxygen. And as water heats up, it can't hold as much oxygen in solution. So every year we do see, you know, as the temperature increases throughout the bay, and this is using Annapolis data, you can see the dissolved oxygen actually does decrease throughout that year. And this is a known issue within the Chesapeake Bay watershed, known as hypoxia or anoxia, something that we see. And I don't know if people are tracking the news on this recently, but they're calling for maybe it's going to be a rough year for hypoxia this year. So this will be an interesting one to look at and track. And then for our folks throughout the watershed, you know, when we think about using data in the context of a meaningful watershed investigation, a MWEE, we can often turn to the news to identify like where some big issues are. And I'm sure many of us are aware and have heard about all the stuff that was happening this fall in terms of all the precipitation we were getting out the watershed. And it led to some big issues. Conowingo Dam was one really big source of concern with all that stormwater runoff and precipitation. And you know what was happening as water flowed over that dam and through the dam, and they opened up the gates. And there was a very real impact of that, you know, the precipitation in the Susquehanna watershed. And when the dam was opened, seeing all that sediment that made its way into the Chesapeake Bay. And, you know, we have yet to see what the impacts necessarily of that are, but it was sediment that came in as well as a whole lot of fresh water. And just to put that all in perspective, because I think it's really cool, you know, and this is also data that is accessible, that, you know, the precipitation that we got in August in the Susquehanna was about 13 inches. The average there is about 3 1/3, and it was 9 inches more than what was typical. 14 inches more than what was typical over the course of the year. And you can see how these unique weather-driven, you know, possibly climate-driven events led to some interesting results. And what we see here is kind of to put things again in perspective, the kind of what's normal is the light green. So that's how much rain you expect to accumulate over the course of the year. And we were above average last year, beginning in June, with some pretty big spikes in terms of when our numbers went up. And so we were way above average for the year in Baltimore, like the Susquehanna. And when you think about this, the sediment that came in, all that rain that came in, there might have been an impact on some of the critters that live in the Chesapeake Bay. And if you want, you can type up some guesses into the chat of what things might have been impacted by this, you know, a tremendous amount of sediment that came in and all that fresh water. And I wanted to go just live for a quick second here, just to take a look at one element in particular. So like I said, Chesapeake Bay Interpretive Buoy System is one of the key resources that we hope people have the opportunity to look at. And you can see from the map up on the screen that there's a whole number of buoys throughout the bay, from the Susquehanna all the way down to the mouth, right? And each one of these you can get a whole bunch of data from And to do that, there's a number of ways you can access it. But the one I wanted to highlight right now is that you can actually graph some of that data. So if I click on the graphing button over here on the right-hand side underneath the real-time buoy data, it brings me up to a tool that lets me, choose the stuff that I want to graph. So because I want to look at what happened, in the Chesapeake Bay right after all that rain, I'm going to go back in time a little bit. So I'm going to pick custom date range, and I want to go back to June, but I want to go back to June 2018. So I'm going to start on June 1, 2018, and I'm going to end, we'll just do a month or so. Let's go August 2018, and let's just say August 12th for the sake of it. And then we want to look at you can choose what platform you look at once you get those dates all set. And we're going to look at Annapolis. And then the parameter that we're most interested in for this exercise is salinity. So when I click all that, I can choose all my parameters, and then I just click load, and up should pop a graph of that data. And so one of the cool things that you see is that this is sort of the normal pattern in salinity, but then as soon as July hit, things changed and salinity dropped precipitously. So that's kind of how you can access and work through some of that live data. We're going to do a little bit more in the breakouts, but this stuff did have an impact, or it might have an impact on critters, right? So here's that salinity graph again. One of the things that we work on a lot in the Chesapeake Bay is restoring oysters. And oysters, they're a pretty hardy beast in the Chesapeake Bay, and they live throughout it. But occasionally, when the salinity gets below 4 parts per thousand, and this is Annapolis, so south of the Chesapeake Bay Bridge, there's oysters that are north of the Bay Bridge. So it's maybe a little bit fresher out there. We had a good period of time where the salinity levels were actually below 4 parts per thousand, which are not ideal for oysters. And that 4 parts per thousand lasted for a good chunk of the rest of that year. And just to put all that in context, salinity in the bay in 2018 is the blue line. So here's that big drop again. The average from the amount of data we have is this black line. So we were well below that. And frankly, the question still remains, how much are oysters going to be impacted by that crush of fresh water that we got in the fall of last year. So time will tell, and it's not all a bad story, but this is the kind of thing, the kind of issue that we can look at through the data that's available on CBIBs. So we just wanted to highlight that really quickly, show that off, and encourage people to think about it. CBIBs, of course, is not the only place where you can get water quality data. Another really great national set of water quality data is USGS, and they do a lot of work up in the stream. So not all bay focused, but up where a lot of us live and work, right? So I highly suggest this as a useful site for exploring both water quality and water level data, so how much water is coming out. And just like in CBIBs, some of the stations in USGS will tell us a little bit about turbidity and other things like that. So they measured, this is turbidity from the Susquehanna River for last year. So you can see that there was a number of spikes in how turbid the water was too. But just to call out to get there. And then, throughout, people probably have their favorite sites for getting local-ish water quality data. And I wanted to ask people to go ahead and chat that in as well. But just a couple to call out. In Virginia, their coastal observing system is called BCOS. And so that's the link to that. It works just like, buoy data, the Buoy Bay site and the CBIB site. Maryland has Eyes on the Bay and their stream health map that is a great resource for water quality data. And then there's the PA Water Quality Network, which is also another really good source of a database of water quality resources. So I'm psyched to see some of these things coming in for other ideas. And we're hoping to archive that and look them up too. But yeah, thank you. So I'm going to turn it over to Chris really quick to tell us a little bit about the other side of the whole water quality data picture.
Yeah, so I'm going to spend a couple minutes and just talk about 2 additional tools you can use with your students. So based on your program, this might make sense to do it before you look at water quality or after or even during. But they're great because they can help students make connections to what's happening on the land and then what's happening in the water. So the first one I'm going to talk about is Fieldscope. So we hope a lot of you at least have heard of Fieldscope. You can go onto Fieldscope, you can create a free account, and we recommend you just kind of playing around with it. There's a lot of different layers you can overlay on your map. You can learn about, you can zoom down to a building, which is up here. We have Arlington County Public School System, but you can zoom down to your school, down to your county, down to your neighborhood, and you can look at things like land cover. You can have different types of map like street cover or topo, and you can gain a lot just from looking at the map. What we have on the right here is actually land cover, and so you see in Arlington, it's really just a mix of like medium or high density impacts on the land. Another cool resource, so if you want to switch to the slides, is so students can think about the land impacts that's happening around their schoolyard, in their neighborhood, and then to make that connection to the bay. We've heard from a lot of teachers that they like this function of Fieldscope. It's showing the flow path of water that falls at a point and how it gets to, eventually how it gets to the Chesapeake Bay. So you could go to this map, you could zoom in to your schoolyard, you could click on a point, and it's going to draw this blue line and show you exactly, all the little storm drains it would take, all the little tributaries, and eventually how it would get to the bay. And from this, we also learned that from this particular point, it takes 143 miles to get to the bay. You could take it another step, and not only could students be thinking about what's happening on their schoolyard, but as they follow that flow path, they could be looking and seeing what else is happening around their watershed that could be affecting the water quality of that water before it reaches the bay. So if you want to go to the next one, Bart. The other tool we wanted to talk about was MWEE Watershed, and this is a really cool tool. So I didn't mention this, but Fieldscope is great because students can input their own data. So they can input water quality data, they can input land data like weather and vegetation that they find. So they can be a lot more interactive with Fieldscope. You can keep going back to it for years, see if data's changed. MWEE Watershed is another tool you can use to learn about what's happening on the land and how that may be affecting the water. So again, just like Fieldscope, you can look at it at different levels. You could zoom down to your schoolyard. In this case, we're looking at a watershed. And so these are watershed boundaries in which the Talbot County Public School System is a part of. And if you look underneath Talbot County Public Schools, you can see that you can actually click through different data sources. So you can look at land cover in this. What we've selected right now is actually soil, because this soil information students can then use in the next slide, if you want to click it, is when you're looking at a runoff simulation. So this is a really cool resource if students want to learn about what happened, especially in one particular rainfall event. So they can go to MWEE Watershed, they can zoom to their location, they can determine the land cover, like is it developed medium, developed low, is it forest, is it shrubland? They'll select that on the land cover. Then on the previous slide, we saw that there's different types of soil groups, and those soil groups are split into infiltration. So is it really densely packed? Is it a little more loose? In this case, our example is it was more of the looser soil, so that means there's a lot of infiltration of water. So they select the proper soil group, and then they can look on the weather data and they can determine, that big storm we had last night, there was 5 centimeters of precipitation that came down. And so you can see up at the left, there's 5 centimeters that came down in this one particular event. And from that, we can learn that about half of it will run off and go into the storm drains, and then another about half of it will be able to infiltrate into the ground. And then if they fiddle around with the land cover in different soil groups, they'll see how things like that can change too.
Thanks, Krista. That's a perfect segue, I think, into weather data, which is what we're going to showcase next. So this is, places where you go to get weather data. This is probably something that you do when you wake up in the morning. If you have a favorite place to access weather data, go ahead, you can share it in the chat, and maybe give a reason why you like it. We can flick to the next page because we're kind of running short on time here. So this might look familiar. Maybe you access the Weather Channel. Maybe this is your favorite app to use on your smartphone, or perhaps you watch the Weather Channel on your TV. But this is kind of a good example of some of the data that we use to make decisions really from the moment that we open our eyes. So temperature, do I need to wear a scarf today or short sleeve shirt? Humidity, should I wear my hair up or down? Visibility and wind, is it safe for me to commute over the bridge today? So all of these kind of pieces help us to make good decisions. You can flip to the next one. Aside from using weather to make decisions about programming, which I'm sure everybody on this call can relate to, we can use weather data in the classroom to meet a lot of needs of teachers. So like we kind of saw in the Capon project, students can collect precipitation observations and record them through efforts like COCORAs, and contribute to citizen science. Or you can even use it to teach your students to explain different processes that they observe in satellite imagery or in plotted weather data. And so one of the largest arms of NOAA is the National Weather Service. This is an agency that's tasked with providing weather forecasts and warnings of hazardous weather to ensure the safety of everyday people. And so because of this mission, much of their website is actually really digestible and it's easy to use for the average person. You can flip to the next one. There's a lot of information on this site that you can dig into. It's worth spending time just kind of poking around and seeing what you can find. But a couple of tips for starting off is that you'll want to find your local weather forecast office. And you can do that by just, typing in your zip code or your city or town like you normally do. But then up on usually the left-hand corner, I believe, will tell you what your local forecast office is, and you'll want to click into that. So for us sitting in Oxford, Maryland, our local forecast office is actually in Philadelphia. And if you follow that, then you'll be able to kind of come to this screen here. And this kind of suite of buttons reminds me a lot of phone apps, and each one has a sort of slightly different lineup of what's available based on the office. And two of the ones that we'll look into now are the forecast maps and the hour-by-hour forecast. So this is the hour by hour. This is essentially a time series. It probably looks maybe a little similar to the water quality data that you saw Bart showing on CBIBs. But you can look at things from temperature and dew point, wind and gusts, relative humidity and sky cover, rain, thunder. So these are really easy to read graphs that can be used with students. They could look at these before going out on an outdoor field experience where they'll be recording probably basic weather observations anyways into their field journals. You could also have them look at a short recent past weather data to consider how precipitation might be affecting the specific phenomenon out in the field. So for example, if we're seeing the example that Bart was showing before of a lot of rainfall impacting salinity, this could be used to kind of help make some of those connections. And flip to the next. The other kind of cool thing here is being able to access imagery that demonstrates similar information. So from the graphs on the last page to these images here, providing students with opportunities to interpret forecast maps and satellite imagery, that can help to drive back to those practices within NGSS. And just like an example that I was reading about this morning, so in middle school, we're asking students to use graphical displays, maps, charts, graphs, and tables of large sets of data to identify temporal and spatial relationships. So this is a great connection, really easy to do. Next page, the one other section of weather.gov that we wanted to showcase is the climate plots page. Again, you can navigate back to that local forecast office page, this app page, like I call it. We can go to the next one. So we oftentimes hear people say, it's so much hotter, it's so much wetter this spring, summer, winter, whatever. This application allows you to put that weather data into context. So these graphs compare observed temperature on the left and precipitation on the right with the normals. So the high and the low are in red and blue. And then looking at the weather data in the overall kind of climate context, this is an important opportunity for students to engage in that bigger systems conversation. Go to the next one, Bart. And so one thing to note about weather.gov, which I mentioned, all the applications aren't consistent between the forecasting office. So not every single one of them has the climate plot option. So we wanted to showcase kind of a reliable place where it's a little bit easier to actually search for location and acquiring this data. So that's through the NOAA's National Center for Environmental Information site, which used to be called the National Climate Data Center. These are the 3-decade averages of climate variables. They include temperature and precipitation, and you can choose basically from a number of parameters to create these visualizations. It's really easy to use. You kind of choose the temporal scale, so monthly, daily, hourly, seasonal, and the location. And from this tool, you can kind of look at long-term average conditions and make predictions about future conditions, or you can compare current conditions to normals. So this up here, after you kind of like select what you want to do, and back in that last screen, you'll get this really nice graph and table that look like this. So this is the monthly normals in Baltimore, Maryland. The red and the green lines are maximum and minimum normal temperatures. The orange is the average normal. You can see precipitation at the bottom. So this graph, easy to use in the classroom. You could have your students consider whether last week's weather was normal. And actually in a minute, Bart will be showing some tools that kind of demonstrate some of the climate trends that we're seeing through the Climate at a Glance tool. But the one other thing I wanted to point out on this page is that it's really easy for middle and high school students to use. They can create their own graphs, but you can also download this data. So if you click the View Station Details page and add it to your cart, you can actually download the data in PDF or CSV form. All right, Bart.
Yeah, and so just a minute on, so NOAA has obviously, like NOAA's job is taking the pulse of the planet. So we have, water, whether it's water quality, weather, or climate data, which also ties so nicely to issues. And there's so many types of data available through the climate source. And these are just a list of some of the things that people might want to look at. But really, the way our climate data is organized is I think, pretty helpful for folks that want to use it for an education context. So first off, this is the climate.gov webpage. Hopefully this is sort of a one-stop shop for you if you're interested in kind of news related to climate, teaching things about climate, or accessing maps and data. And right on that front page, there's this global climate dashboard, which kind of captures some of the key types of data that NOAA regularly looks at and monitors to kind of tell that story about what is happening with our climate, and ideally help us make informed decisions. And from that page, you can get to Climate at a Glance, which is one of my favorite personal tools that helps tell the climate story, because it tracks both global scale stuff, but also you can drill into your state and even, I believe, your county to look at what is going on with temperature, what is going on with precipitation in my county, and actually get that data to make those cases. And of course, so you can look at the temperatures, which is largely the impact of the changes we're seeing in the climate, but you're also able to access the data behind our understanding about what's going on with carbon dioxide levels in the atmosphere. And this is that classic graph of CO2 levels in the atmosphere for mono-level Hawaii that you can download, work with. The same thing like Elise was talking about with the normals. You can do that with CO2 data. You can look at sea level change data and look for trends of that through resources available on NOAA. You can actually even look at what does that data look like when we put it on a map. Like, so if sea levels continue to rise, what are the areas around me look like if you're in a coastal area, if the sea level changes 3 feet. So this is a great example from Dorchester County, which many of you may know is one of those areas that's particularly vulnerable to changing sea levels. So I'll turn it back over to Elise to kind of explain what is up next.
Sorry, I'm still on mute. So we went through a whole bunch of resources really quickly. Again, this is being recorded, so you can access it after this. But this is the part where we want to break out into groups and spend a little bit of time with one single tool per group. So if you completed that one question survey on my email, you should, fingers crossed, be in the group that you requested. Otherwise, we're going to randomly assign you. So we're going to spend about 5-10 minutes in the groups. And to start, Bart, Krista, and myself will do a quick navigational tour of just how to use the data tool. And then you'll have a chance to explore for a few minutes, and then we have some discussion questions to reflect on. One tip for people, if you're having trouble using the tool while you're on Zoom, you just might need to minimize your Zoom screen so that you can see your browser windows. But the facilitators in each room will help you with that. So in just a minute, you're going to get an invite that pops up on your screen to join. When I close the breakout room, you're going to get another notification. Click that, where you'll automatically be sent back into the room. And while we do this, please turn your videos on just while we're in the breakout rooms, because it kind of just helps with conversation and keeping everybody kind of engaged. So since we have 3 groups looking at 3 different tools, we are going to do a quick share out when we get back together, like a 1-minute share out. So please select one person from your group to do that report. So folks can turn off their video now if you don't want to be on video. We're just going to do a really quick wrap up. Maybe if there was somebody from your group that said that they wanted to do a report out, like I know our group we had just like a couple of minutes. So
Yeah.
Bart, did you guys have anything from the water quality group?
I think so. We had a brief but good discussion. So maybe Mary, if you don't mind.
Yeah, I'll do it in 30 seconds. We talked about accessibility. We thought very accessible. There's like maybe a little hump in like getting the teacher to understand how to work it the first few times, but once you get that, it's really useful. We thought there's a lot of potential investigations. One that some of us were talking about was comparing like turbidity over different months for a period of years, maybe, and then comparing that to how impervious surfaces have changed over a variety of years. And then a final suggestion we had was Cassie had a teacher bring a math person to help them with the Excel. The science teacher wasn't as comfortable with that, and so they found that very useful. So maybe leveraging some partnerships with some of your colleagues at schools.
That's perfect. Thank you. Krista, is there anybody from your group?
Yeah, Kathy was going to talk about climate at a glance.
Yeah, so we looked at NOAA's website, Climate at a Glance, and it has temperature and precipitation data that goes from the global scale all the way down to the county scale with different levels in between, which I think is very nice in terms of looking at spatial reasoning and thinking about what's happening at different scales. And it does go down to the city level, but Krista had mentioned that can be limited. So for some areas, county level is probably best. So I was looking at the county that we're focused on, and just kind of playing around with it. And it has a mapping feature, a time series features that's graphing data, and then also a rankings tab. So all of the years then get ranked in terms of how much above average or below average they are for either temperature or precipitation. And then they also included the Haywood plots, which sort of shows the trends on a monthly basis and how it's changed over time. And it'll highlight the top 5 years that are above average and the top 5 that are below average that make them pop out with color. So it's kind of nice to see that. And I think also you can download the data in an Excel spreadsheet. So if the teachers want them to be able to do some different kinds of graphing or analyses, they can. Because we actually have a math class that will be developing curriculum for the high school level. And I think this would be really nice site to use.
And so I'll do the quick report out for our group because we had the sea level rise viewer, which helps you to kind of visualize community level impacts from coastal flooding and or sea level rise. And this one takes just a little bit longer than the others to load. So we're just, I think, 2 minutes behind everyone else. But we did have some good discussion. Tara from up in Pennsylvania was talking about how this is a really good visual for students who have never been on the coast before. So this really puts things into perspective. You're able to kind of connect those issues and just having them be able to see that is really important. And Al was mentioning there's also part of this, there's flood frequency in, or there's a layer that's specifically looking at socioeconomic vulnerability. And he's working in communities where that are actually kind of on this higher end of vulnerability. So just helping students to recognize kind of where they are and the fact that they're more at risk could be, you know, really enlightening and might get them more invested in the project. So we had a really great conversation too. So I know we are over time. Thank you everybody for a really good discussion. We hope that this webinar kind of gives you an idea of some of the resources for accessing data that are out there. But if you have specific needs for data and resources as you're developing and tweaking your MWEE, don't hesitate to reach out. If you can't tell, Bart is really our data guru in the office, but we're all here to help. So just 3 really quick announcements before we conclude. We're going to be resuming this webinar sequence in the fall. We know summer's too busy for folks, so look out for something in September or October. If you have ideas for topics that you want to see, feel free to email us. We're looking at things like curriculum integration, student action, evaluation, and maybe even a synthesis of kind of best practices for MWEEs across the years. We'll be sending out this webinar as well as the last one with the recordings. And if you are planning to use the MWEE 101 course this summer, which we hope you will, in your professional development, don't hesitate to reach out and ask us if you have any questions. And then finally, if this webinar sparks something for you and you want to learn more about data, we are hosting a Make a Date with Data workshop this fall. We'll be modeling data activities. We'll be thinking about storytelling with data, and you can even make your own CO2 sensor to take home. So stay tuned for details. If you're interested in that specifically, feel free to drop us a line and we'll make sure that you're on our email list for that. So thanks everyone for joining. We will stick around for a couple minutes if anyone has questions. Otherwise, feel free to email us and we're always here to help. So thank you all for coming today and for your active participation.
Cool. Thank you, everybody.
Thank you.
Thank you.
Thank you.